Hong Kong's public transport is vast and heavily used. Millions of daily trips across MTR, buses, trams, ferries, and minibuses keep the city moving and limit car dependence. Yet there are still many residents facing long, indirect, or transfer-heavy journeys because rail doesn't reach everywhere and direct bus links are limited. In this video, we hope to pinpoint these gaps in the accessibility of Hong Kong's public transport network and recommend tailored fixes to make the system faster, fairer, and more resilient. So, how do we assess the accessibility of Hong Kong's public transport network? First, let's define the word accessibility. We want to look at how easily the population can access public transport, how fast and convenient the network is. Thus, we have analyzed the time efficiency for workers to reach workplaces using direct bus linkage and time for the populace to reach their nearest public transport service. First, let's look at how we calculated the direct bus linkage. We combined 3 open government datasets: bus stops data, route data, and district boundaries data. Our methodology consisted of 4 key steps. First, we took the coordinates of every bus stop in the city and mapped them into their specific districts using the district boundary data. Second, we extracted every bus route available within each district by identifying the routes that pass through the bus stops in the district. Third, we expanded the network by retrieving the full list of stops reachable by those specific routes. Finally, we aggregated these reachable stops by their physical districts. This allowed us to quantify the direct bus linkage between every district pair in the city. We used heat map to visualize the bus network coverage, showing the origin-destination matrix. The result indicates that North, Sai Kung, Southern, and Tuen Mun exhibit the lowest levels of direct bus connectivity. This limited network reach creates a significant disparity in commute times for passengers who cannot or choose not to use the MTR. The impact is most acute for residents living outside the railway catchment area, particularly in Sai Kung, where the complete absence of MTR infrastructure leaves the population entirely dependent on this limited bus network. To solve the problem where some districts lack direct bus connections to the other districts, we can leverage the bus-bus interchanges. Instead of adding new point-to-point routes, we should introduce frequent shuttle buses that connect the isolated estates to the nearest highway interchange, such as the Tuen Mun Road and Cross Harbor Tunnel interchanges. By getting the residents to these high connectivity gateways, we unlock the entire bus network for them so that they can reach all the other districts. This solution bridges the connectivity divide without requiring massive infrastructure changes. Next, we estimated the average first-mile walking time for the populace. We mapped population-weighted distribution to a grid with population census and building footprints, computed the walking time to the nearest public transport stop with the pedestrian network from OpenStreetMap, and aggregated the results by districts. This map shows the average first-mile walking time per district. We found that Islands and Tai Po have the longest mean walking times of over 4.5 minutes, while Yuen Long, Tuen Mun, Sha Tin, and Sai Kung all exceed 4 minutes. This map shows a more detailed TPU level of average walking time. It reveals localized pockets of poor access, often due to long distances or missing direct pedestrian links despite nearby stops. These findings identify underserved communities where adding stops or improving pedestrian infrastructure, like sidewalks and direct links, would reduce first-mile times. To fix the first and last mile, invest in continuous sidewalks, safe crossings, lighting, and direct pedestrian corridors where walking times are high, especially Islands, Tai Po, and Sai Kung. Remove barriers like missing footpaths and indirect detours. Add clear wayfinding, strategically place bridges and tunnels, and co-locate stops with secure bike parking and micromobility hubs so transfers are safe, fast, and seamless. Then, we can let big data guide decisions. Combine richer population and mobility data with our routing model to pinpoint high-impact interventions. Build and test new pedestrian links, and measure real changes in travel time before scaling. A shorter commute isn't just a nicer morning. It boosts productivity, frees up family time, and raises people's quality of life. But in Hong Kong, not everyone shares that benefit. Some districts face long, indirect trips and poor first-mile access. Solving these inequalities in the public transport network can help narrow not only the spatial inequalities, but also economic and social inequalities. Together, these steps, smarter bus design, stronger pedestrian links, and data-driven pilots, will shorten door-to-door journeys, boost fairness, and make Hong Kong's transport system more resilient and inclusive.